In this slidecast, we're going to cover all of the remaining sections in Chapter 1. Now, these sections all deal with the telephone directory program example that's given in your book. And parts of this contain the actual code and design artifacts related to designing this program. And so some of this you need to look at on your own. So what I'm going to go through these slides, some rather briefly, and I just want to explain some of the tools that are talked about, which will be useful to you as you do your programs. So I'll focus on these, and then you need to you can pause the slidecast and take a moment to study the code examples that are here, or you might want to get your book and have that beside you and study that at the same time. So I'm expecting that you're going to need to spend a little bit of study time on your own beyond just the slidecast. So this telephone directory, remember, this was a program where we store the names and numbers for individuals in a phone directory so that people can look them up and can add new entries. So in this phone directory example, we have for inputs, we can get initially some information from a data file where we have names and numbers on separate lines, or the user can also be prompted and can enter the data. And then for outputs, when the user enters a new number, that can be stored in the directory in memory. And then when we exit the program, we're going to write out the phone directory to disk. So we've always got a permanent copy that we can come back to the next time we run the program. Now, the first concept that will be useful to you is the idea of a use case. So a use case is a list of the user actions and the system response for a particular subproblem, in the order that it's likely to occur. So earlier we've seen examples where we use top-down design to take the problem of the telephone directory and to break it up into subproblems. And a use case is the idea is that we start with actions that the user does. So the user can issue a command to the operating system to load and run the phone directory program. So the user starts up the program, and then when the program is started, it initially reads from the data file and initializes the contents of the directory. And then the user can issue commands, maybe to insert or change an entry. And in that case, the system might prompt for a name that the user enters. If the user enters a valid name, then it can prompt for a number. And if that's valid, then the directory can be updated, either add a new number or change an existing number. And here the user issues a command to retrieve and display an entry, and the system prompts the user for the name, and it goes ahead and displays that information. So this is just a step-by-step kind of scenario of what the system does interacting with the user. And this is maybe a helpful thing for you to think about when we assign you programming labs that involve a hypothetical user who interacts with the program and gives commands. And you can start out in your initial design and analysis to sort of enumerate exactly what the system should do as it interacts with the user. Now, there's some other discussions in the chapter that talks about there might be several ways we can solve this problem, and they break it into some subproblems and find out that they can get some code reused by combining some aspects of some of the subproblems where there's some similarities. Another way they look at the problem is they think of it as, well, we need a user interface as the front end, so the user sends commands to a phone directory application. This is where the phone directory application is what starts up, loads up the phone directory and prompts the user. And then we've got a database. That's what a persistent storage on disk. That's sort of the back end for this system. And here's the phone directory is an abstract data type where we've got 5 functions that phone directory should support. And it's an interface, meaning all we have are these public methods, and we don't have any data items defined for this phone directory. And this is a UML diagram where this black diamond here on this end of the arrow signifies that phone directory is a class that's contained in our phone directory application. So this is the has a relationship that you might have discussed in 142. So the phone directory has a phone directory object. The phone directory application has a phone directory object. And that's what this arrowhead implies. So that makes it an ADT. And then once we've defined this sort of logical abstract interface, this relationship between the application and the phone directory, then we can work on these two parts independently. And the PD application just assumes that these public methods exist, and it can write the main routine and make use of these functions, and then somebody else can actually implement them. So here's a listing of classes that we might need for our application and a description of what they do. Remember the hint earlier on in Chapter 1 that we can often think about the nouns in a problem statement to define the classes. So we have directory entries and the phone directory itself. And then since we're dealing with files, we need some input and output streams. Now here's the algorithm for the main function. The main function sends the phone directory a message to read the initial directory data from the file. So this assumes we would create the phone directory object in our main function, and then we read commands from the user by prompting the user for a command, and then sending the appropriate message to the phone directory object to execute that command and display any results to the user. Now here's a sequence diagram. And a sequence diagram consists of maybe the user and the objects associated with our application. And then we illustrate as we move down the figure. This represents time moving forward, and this shows the messages that show interactions between these objects. So the user starts up the phone directory application. This solid blue line represents the time that this object is in existence. And the PD application instantiates, initializes a phone directory and calls load data, which causes the phone directory object to call the input file stream. It reads in a line at a time and adds names and numbers to the phone directory object, and then closes the file when it's finished. And then the user processes commands against the directory. So a sequence diagram, let me back up this. So the sequence diagram could be a useful way for you to think about the objects in your programs and how they interact, and again, kind of the ordering of how things happen. Let's say some more about the design of this array-based phone directory. So here's another kind of UML diagram. It has some of these same entities, but here we've done a little bit more detailed design, and we've determined the operators and the data members for our objects. So here are two methods or functions we'll have in our PD application. Here's our abstract data type definition. And now we create an array-based phone directory class that inherits from phone directory. So that means it supports these methods as public methods. So these are the public methods that it supports. And then a directory entry has two private data members, namely name and number, and some public operations that it supports. And here's a list of some data fields, constructors and functions, and a description of what they do. You can pause and read this over carefully and then continue when you're ready. Now this slide shows the data fields in the array-based phone directory class. We have an initial capacity, which is a constant, and then we've got a capacity and a size field. The idea is that when we create this array-based phone directory, we'll create an array of a certain capacity, and then size might initially be 0. There won't be any entries in that array. And so we'll start filling it up one by one, say when we initially read it from a file. And when our size equals our capacity, that means our array is going to be full. Then we'll have a reallocate step where we'll create a bigger phone directory, copy the current results into that, and then that'll have some open entries that we can continue to add to it. So that's what size and capacity are used for. Now here's an important field that maybe you want to spend some time in. I'd like you to see that if you understand the code. This is a kind of a use of pointers, and you had a little bit of experience with that in 142. So the directory, its type is a pointer to directory entries. And with that, we can create an array of directory entries. And the directory has the address of the first directory entry in the array. And then we have the name of the data file that's associated with the directory. And this modified flag is there so that when we're working, if we read in a directory and we never modify it, then our program can just terminate. But if we've made some changes or added new entries, then we need to write it back out to disk so we get the new information. Now, some member functions in this class. We have a load data, and here's the pseudocode for it. And you can pause and look at this and see that you understand it. Here's to add or change an entry. So when we want to, we call the find function to see if a name already exists, so then we can change the number, or else we just have to add a new entry if it's a new name that's not in the directory. Here's a lookup entry. It needs to it just sequentially looks through the entire array to see if the name exists that we're looking for. And here's a save function that writes information out to a file. Okay, now here's a UML diagram. It just extends what we've seen before. It has the same public functions, but we add here some private operations or functions. So these are some functions that the programmer makes use of while implementing these public functions, but they just need to be internal to this class, so they're private. And here are the private fields that we saw in that earlier chart. Now, implementing and testing this directory, here's the private functions that were introduced in a description of what they do. For example, here's this reallocate function I was mentioning, that if we create our initial directory and we fill it up, then here's a way that we dynamically expand and get a bigger directory so we can keep adding entries. Pause and read these descriptions. Now, there's a set of slides here that have the actual C++ code, and I'm not going to walk you through it here. We may talk about this in class, so you pause these slides and you can take a minute and look this over or consult your textbook. So I'm just going to continue through this code, and what I want to go to here in a little bit, we'll get to this final slide on testing as an important example. So once we've built this class, we want to test to see that it works correctly and that we've handled all possible cases. So here's a list, sort of a listing of the kind of some various alternatives that we could create tests for. So we'd like to run this program and see if the data file is empty, that it works okay. Maybe the data file contains a single name and number pair. What if it has a name without a corresponding number? We need to be able to handle that error condition. What if we run it with a completely filled array and try to add a new entry to make sure that our reallocate function works correctly? We can try to retrieve names that are not there. We can verify that if an entry is changed, the new number is retrieved. We can check that we write new information out to the output file. So this gives you an idea. When you have a specification, you write your program, you have to think carefully about all of the various alternatives that are supported in your code and create test cases to verify that they work as expected. Here's a list of the menu choices that the user is given for this phone directory example, and we'll prompt the user for actions. And there's code in your book that shows that this is that main application that has the main routine. So come and look at this and see how this menu is chosen. You'll be able to maybe write a main routine similar to this to do some of your programming labs this semester. And that's the end of this Slidecast.